Lesson 3.4. This lesson we're going to be discussing using similar triangles. The warm-up. Let me click on it. So you're solving for x. So you're combining like terms. What property are we using to simplify this?
Distributive.
Very good. Distributive property. 7th grade just did all this. Distributive property, and then rearrange till you have solved for x. All right?
Yes.
Then once you've done that, make sure you go do your vocab and key ideas.
Yes, ma'am.
All right, here is warm up, the first one. So we have 5 times 5 minus 7x equals negative 6 times 6x minus 7. Okay, so the first thing we need to do is distribute. So we're going to do 5 times 5, 5 times negative 7. What's 5 times 5?
25.
5 times negative 7?
Negative 35x.
X. X.
Thanks. Okay, now we distribute over here. Negative 6 times 6.
Negative 36x.
Very good.
No, 42.
Negative 6 times negative 7.
Positive 42.
Positive 42.
No X.
Oh, okay.
All right, so now we combine like terms. So I'm going to move this x stuff over here and then the non-x stuff over here. So if this is a negative 36x, how do I move it?
Add it to the other side.
Yep, so add 36x plus 36x. Okay, so this cancels and I'm left with 42 over there. I'm not doing anything with the 25 yet. What is negative 35 plus 36 equal? Positive 1, right?
Or just x.
Or just x. Now I need to move the 25 over here so that we get x by itself. So it's a positive 25, so I'm going to subtract 25. So that cancels. I'm left with x equals, what's 42 minus 25? 17. All right, so that's your first warm-up example. Now go do the second one if you have not. I'll leave that up for just a moment. All right, somebody tell me, what does indirect measurement mean? Camille. Camila. Go ahead. Indirect measurement. Don't hate me.
Similar figures to find a missing measure when it is difficult to find directly. Yes.
I like the support. Yes. Sorry, I'm laughing. Yes. So, when we are looking at these two triangles, you can see that triangle ABC is already listed that it is similar to DEF. If you notice, what they're saying here is if you look at these three angles, 95, 65, 20, 95, 65, 20, the angles are the same in both triangles, which makes the two triangles considered similar. That means we could write the lengths of the angles as proportions, or lengths of the sides as proportions, right? Good. If you only know of two triangles, two angles, man, my words are failing, that are congruent, then the third one, if these two are, like if we already know that this is 95, this is 95, 65, 65, we know that the third angle of both of these triangles is also congruent because all three angles add up to what? 180. So as long as they're congruent, then you would have the same angle measure. All right, let's do an example.
Yay.
So we're going to tell whether these triangles are similar. So let's look at the red. We have two angle measures of each of these. Can we compare x and y?
No.
Wait, no.
What? Wait. Yes.
No, you can't.
Yes.
Yes, you can. We have an angle 75 and angle 75.
Oh.
We have an angle 50 and an angle 50. Are x and y going to be congruent?
Yes, ma'am.
Yes, because no matter what, they add up to 180, right? So the third angle is congruent, so you could say that these triangles are,
Congruent.
and the word they're looking for is similar.
Similar. Wait, what?
Similar is the word you're looking for. All right, let's look at the green triangles. Okay, we see both triangles have a 90 degrees. The second measurement, are those congruent?
No.
No. So can we assume x and y are congruent? No. We would have to write and solve an equation for x to see if x equals 38. So let's do that. Do you have a question? What's your statement?
So, isn't the one on the
No.
right basically just the one on the left? But
Flipped over? Yes, but we don't know for sure whether the angles are the same, so we have to solve.
Stop.
Okay, so we can't compare x directly to y, but we could see if x equals 38. So we're going to solve for that. So what's 90 plus 42?
132.
132.
Yep, write this in your journals, guys. And then we subtract 132 from 180. What do you get?
48.
48.
So does x equal this measurement on the other triangle?
Totally not.
No. So then these two triangles do not have two pairs of congruent angles, which also means they're not similar. Okay, so how many angles have to be congruent for you to assume the third one? Two. You have to have at least two congruent angles comparing triangles. If you don't have two congruent, you cannot assume the third one is congruent. Okay, go do your try-its. Gotta say it all over again. Can you determine whether triangle JKL, this is the smaller one, and JMN are similar? What are we looking for when we're comparing similarities in triangles?
Angles.
How many?
2.
Two congruent angles. Is there any congruent angles within these? Well, yeah, J would be congruent to itself, wouldn't it?
Yes, ma'am.
So there's one.
Yes.
Is there another one?
Yes.
Which one?
J and no, K and M.
K and M. He says K and M are similar. Are there any other ones? Aaron?
K&L.
Nope.
Oh.
Maybe you should not talk while I'm talking. Daisy. L and N. Okay? Yes, because they are written and these two lines are parallel to each other. Ooh, we're going back to the transversals. You can say that L and N are congruent because they are corresponding. Remember, they're in the same location on the parallel lines according to the transversal. We learned that. And then K and M would also prove it, but they just chose L and N. So yes, these two triangles would be considered similar. Questions? Yes, the smaller one, and then the bigger one. Let me draw it. JKL's this one, and then the bigger one. Oh, it changed colors.
That's so
Magic.
I've never done that. That's a lovely drawing of a triangle there.
Oh,
That's my foot.
it's a mosaic.
All right, go do your try-its.
Okay.
Try it number 3, self-assess 4 and 5. Go, go. All right, example 3, get your journals.
Okay. I journal.
Oh, I like this example.
Oh, yeah, I do
That's
too.
sad. I remember examples from year to year. All right, here we go. So you plan to cross a river and want to know how far it is to the other side. You take measurements on your side of the river and make a drawing as you see here. So my side of the river, I'm right here. On this side of the river, I made a triangle, measured the 90 degrees, and then I am trying to find how far it is across. Do I have two angles I can say are congruent?
Maybe.
Sure.
B and E would be congruent, right? Because they're both 90 degrees. Is there another pair of angles, Sydney?
Well, this is not what you're asking, but isn't X just 60?
No.
No?
Samuel, what is my other pair of angles?
Add A and D.
No.
Oh,
We don't know that A and D are congruent. There's no sign to tell us they are. Josh?
About 40 feet and 50 feet.
Angles. Elena? B and E are congruent. We've established that. B and E, they're both 90. What's another set of angles?
DNA.
B, C, and E.
No.
Okay.
A.
C and E.
This is sad. Okay, So,
Yay.
look at these two triangles. I have ABC, and then I have DEC. Is there a set of angles besides E and B that would be the same?
Yes.
Samuel?
Okay, you have C, D, and E, and you have B, C, and A.
No.
What?
What? Oh.
All you did was rename the 90-degree angles.
Oh.
You just named them fancier. That's fine. Elena?
D, C, E, and
I'm looking for a one-letter answer.
oh.
Sydney?
C.
C. This angle right here and this angle right here, do they form an X?
Oh.
Oh, yeah, I guess so.
That would be a... What kind of angle is that?
Gotta be
Congruent?
Right here, it is congruent. But why is it congruent?
Because it crosses over each other.
Because it makes an X. Shh, what is an X angle? What's that called?
Vertex.
He's close.
Vertical angle.
Cold.
Vertical angles. Okay, vertical angles are congruent. Okay, so if I know that C is congruent to C, do I have two angles that tell me these triangles are similar?
Yes.
Yes. When we know angles are similar, what can we say about their sides? We can form a...
Oh.
Angle.
I said it at the very beginning of the lesson.
Shape.
X.
What's it? Indirect measurement.
Angle.
Y'all are stressing me out.
What was the question?
Proportion, guys.
Oh, smoking crack.
Proportion. So I did. Remember at the very beginning I said if we know that the angles are all congruent, then we can create a proportion with the sides.
Oh, yeah.
We've done this in another lesson.
Yeah.
It concerns me. So I can say
Just go to the back of my arm.
this small triangle base compared to this triangle base, so that would be 40 over 50, should equal x over 60. So I can say 40 over 50, because that's a proportion of the two similar triangles, equals x over 60. Then how do I solve for x? Cross, multiply, and divide. Now let's see if this is how they wanted you to do it. Oh, yeah, see? Vertical angles, right there. Okay, so yes, here's your proportion. 40 over 50 equals x over 60. Cross, multiply, and divide. 60 times 40
Number.
is a number.
It equals
I was
48.
so close.
202,400, yes. Divided by 50.
48.
48.
48.
So the distance across the river is how far?
48.
48 feet. All right, so you guys need to write in your journals about proportions that I just talked about since you didn't remember it. So if we know angles are congruent between two triangles, their side lengths can be written as proportions. You need to know that, or you're going to stress over your homework.
Oh, no,
Already
I
do,
don't like
it's fine.
stressing.
Okay? Please write that in your journals.
Okay.
Okay.
Oh, God.
If two triangles have congruent angles, their side lengths can be written as a proportion. Their side lengths can be written as a proportion. Okay, because then you can solve for the missing variable. Okay, you have two more self-assess, and then you're done.